Hey everybody, I wanted to give a homework help video for tonight on solving one step, one variable inequalities. Here is our first example. The variable n divided by 4 is greater than or equal to 3. We want to isolate the variable with an inverse operation. That means we want to do the opposite of what's being done to the variable right now. So right now, n is being divided by 4. So we want to do the opposite of that. So that's what we're going to do. The opposite of dividing by 4 is multiplying by 4. So we're going to do this to both sides. So we're going to multiply this side by 4, and we're going to multiply this side by 4 as well. An inverse operation on the left side is going to cancel some things out. That means that dividing by 4 and multiplying by 4 are going to cancel each other out. And that's going to leave us with just the variable n by itself. Still greater than or equal to, and now we can multiply 3 times 4 to get 12. So our final answer is that the variable n, whatever it is, has to be greater than 12, or it can also be equal to 12. So on a number line, we would just put some spots on here on a number line. And we're saying that n can be 12 because it says it can be equal to it. So we're going to represent that with a completely colored n circle or dot at the number 12, and this says it can also be anything greater, so it can be equal to 12 or it can be greater than 12, which would be everything else in that direction. The hint here is that if it's got that little equal to, then we're going to color in the dot right there. If we don't, then it would be an open circle, like another example I might show you here in just a minute. Let's solve another one. Let's see. Let's try let's get rid of this example. And let's try s plus 5 is less than or equal to 14. Or let's just do less than 14. We'll show you one of those right now. S plus 5 is less than 14. So let's isolate the variable with an inverse operation. So the variable is over here on this side of the equation right here. So let's isolate it by doing the opposite of adding 5. So let's take away 5, but let's take it away from this side, and let's take away 5 from this side. Taking away 5 from this side is going to cancel each other out. Plus 5 and minus 5 are going to end up making 5 zero pairs, or however you want to say that, cancel each other out, and we're left with just s, still less than, and 14 minus 5 is 9. So s, whatever the answer is, s has to be less than 9. One of the things our 6th graders are struggling with is that in this situation, since there's not this little mark underneath it, it's just less than 9. 9 is not the answer. 9 can't be a part of the answer because it has to be less than 9. So unless it has this right here, 9 can't be a part of the answer. It does not. So on our number line, let's place 9, and let's place some other numbers around 9. And we're going to indicate this one with an open circle because it can't be 9. It can't be equal to 9. It can only be less. So all of the possible answers are in this direction, meaning It could be 8, it could be 7, it could be 6, it could be 5. It could be 8 and a half. It could be 8 and 9/10. It can be anything all the way up to 9, but it can't be 9. It must be less than 9. Let's look at one of our more tricky situations. We looked at some tricky situations in class today. Let's look at one of those. When you're solving inequalities, you can have a situation where you have to flip around the inequality symbol. So here's an example of that. Let's start with, let's say -6 times x is greater than 12. You might be able to notice right away that this is one of the tricky situations, because in order to isolate x, to get x by itself, when we do the inverse operations to both sides, the opposite of multiplying -6 is dividing -6 from both sides. And the tricky situation says if you are multiplying or dividing, in this case we're dividing, if you are dividing or multiplying by a negative number, then you've got to take your inequality symbol and flip it around. So when we go to solve this, these two will cancel each other out again, leaving you with just x. But since we divided by a negative number, we're going to flip that inequality around. 12 divided by -6, using our rules of integers, that is -2. So x has to be less than -2. So if we were to graph this on here, remember, negative numbers look like they get larger as they go to the left, but they really don't. They're getting more negative as we move to the left and more positive as we move towards 0. So we're saying this has to be less than -2. -2 is not the answer. It's not one of the possible answers. It has to be less than -2. So we shade in this direction. If it had this underneath it, we would fill in the circle, but it does not. So it's got to be less than 2. So why do we have to flip the symbol around? Why is that there? So what we could do is we could say, okay, I can pick a number less than -2, and I can plug it in for x. And if I do, the answer should be greater than 12. So let's try and think about that for a second. The original problem was, let me get rid of my number line for a second, give us some more room. Okay. The original problem was -6, and now instead of x, I'm going to plug in something less than -2. So let's see, -3 would be less than -2. So remember, something less than -2. So I've chosen -3 is greater than 12. Well, I know that a negative times a negative is a positive. So 6 times 3 would be 18. And is 18 greater than 12? Yes, it is. So any number I choose, again, less than -2, will work. Let's go back and see what happens if we choose something. Let's try -2 itself. Remember, this can't be -2 unless it has that little thing underneath there saying that it can be equal to. But so -2 shouldn't work. Let's plug in -2 and prove that it doesn't. -6, now we're going to plug in -2 for x is greater than 12. Well, negative 6 times negative 2 is 12, and 12 is not greater than 12. So this is false. That is not going to work. And the same thing would happen if we picked a number larger than negative 2. For example, we could pick anything. We could pick negative 1. That's larger. We could do that. Let's see if that's really greater than 12. Let's see. This would be positive 6. Negative 6 times negative 1 is positive 6 is greater than 12. That is also wrong or incorrect or false. So when it really says whatever you're plugging in for x has to be less than negative 2, they mean it. And you can tell just from our test right here, from plugging in a number that's not less than negative 2, you see what happens. So the only time you have to flip the symbol is if you multiply or divide by a negative number. And if you can remember that, you should be good. Good luck tonight on your homework.